Hi, my name is Jesse Ernst, and this is the project proposal for Team 8. To start off, we have our problem definition and requirements, which you can see here. The most important requirements we had outside of each person having to create their own instrument and each instrument having to play the parts as in the requirements are that they all must fit in the 2 by 2 by 2 foot box. We have to come in under the length and size requirements for the pipe and wire, and that we spend no more than $15 per individual. Our top goals when designing these instruments were the size of the instrument, make sure it fits, the cost of the instrument, make sure it stays under budget, and the time it's going to take us to make the instrument so that we can come out of this project on time. I'm going to turn this over to Leonard to intro his instrument, and I will see you at the end of the video.
Hello, my name is Leonard Galloway, member of Team 8, and I have the opportunity to design and construct a percussion instrument for my team. The percussion instrument that I chose to develop is a xylophone. I will be using steel bars for the keys of the xylophone, which seem to be the best choice given the cost and physical restraints of this project. The song my team decided to play is Alma Mater, and my part is the mid-high voice. Before calculating the required lengths of the bars, I researched the frequencies of the notes that were needed for my part of the song, as well as the speed of the sound in steel. Using the formula to calculate frequencies and lengths for a percussion instrument in our class acoustics activity, I utilized MATLAB to come up with the theoretical lengths of the steel bars that would be required for the notes I will be playing. For the mid-high voice, I will be playing 7 notes ranging from B flat 3 to G4. To construct the xylophone, I will cut the bars into the required lengths, drill holes in each end of the steel bars, and slide them onto small rubber stoppers nailed onto a wooden frame. The xylophone dimensions are as follows: approximately 12 inches long, 3 inches high, and 12 inches wide. The total cost of this project is $14.65. That concludes my portion of this presentation. Thank you.
Hello everybody, my name is Filip Krastev and I'm part of Team 8, also known as Lightning Bites, and I have the pleasure and the honor of designing and building a pen pipe, which is the windpipe instrument for our team for the Bend in a Box project. Our key features that I want to talk about is the tuning capability, number of tubes and size. Tuning capability, fine-tuning capability that this instrument has is because instead of permanently closing the bottom ends of the tubes, I'm using corks that are able to move up and down the tube to be able to fine-tune them. In essence, shortening or lengthening the wind tunnel. The number of tubes is important. When I started designing the project, I had in mind a full octave, so I was going to build an instrument that spanned from D4 to D5. See all the formulas that I used, the calculations that I made as far as frequencies and pipe length. You can see the materials that I'm going to use and the quantity of each material. So the instrument is going to be built out of 3/4 inch red and yellow Schedule 40 PVC pipe, corks, I mentioned them earlier, white duct tape, and black yarn. All the materials used amount to $14.86, so that's within 14 cents of our budget. You're going to be able to see how everything comes together. The total width of the instrument is 21.34 centimeters, and the total length is 29.2 centimeters, and the thickest point is 5.34 centimeters. So you can look at the sketch to see how it's going to work. I hope you can see the corks and the idea behind them. So that is it. Thank you very much.
Hi, I'm back, and this is my instrument design. It is a single string bass. To start off, the important features are that its full design is 1 foot 7 inches in length. It fits within the box. The design features a small tourniquet on the bottom to tension the string. Instead of having to just have it at a set tension, the string can actually stretch and you can still tighten it. And the frets are made of thin metal, which are paper clips, so you can do slides on the actual bass itself. For the physics of how this is actually going to work, each fret, as you can see on my slides, is set at a length determined by the string instrument equation that we got in the acoustics lab. And the tension that is necessary to be on the initial string, the calculation is also in the physics section on the slide. For budget and materials, I have the 1 foot by 7 inch dowel, the tourniquet dowel, which is a 1/2 inch wood, 3 feet of guitar string, and 12 paper clips. Finally, I have the sketch of my design, which you can see the top, front, and side views of. And lastly, we have our justifications for all of our choices that we made. As you can see, we showed you the equations and calculations that we used to make sure our instruments would work. All of our instruments are also historical instruments that have progressed to the main day, meaning that they do actually work as instruments. And then you can see our decision matrices, which we use to make the decisions on which instruments. The reason we didn't choose the top instrument out of any category, though, is because the overall high score, the kazoo, we weren't sure actually fulfilled the requirements for a wind instrument. So we had to choose the panpipe, which meant that we had to choose the bass and xylophone for our other 2 instruments to go along with that to fill out the ranges. So to conclude, Leonard is designing our xylophone to play in the mid-high range. Philip is designing our panpipe for the high range, and I am designing our bass for the mid-low and low ranges. All of them will fit in the box and cost less than $15. Thank you.